All right. So I came across this really quite a cool article by Josh Mandel. And for those of you who don't know who Josh is, he's the founder, creator of like Smart on Fire and a lot of the firework being done in the US right now. I think he's quite a big figure. He's quite a legend there. Now he recently wrote about a UX for what prior authorization and clinical tasks might look like with the coming of LLMs. And I think he's been talking a lot about this. Let's just go into what this might look like and just give you an understanding of all that's happening in here, right? So clinical workflows are full of necessary steps that don't happen instantly. Think about prior auth, a classical example, but also tasks like matching a patient to eligible clinical trials or coordinating a complex specialty consult requiring information exchange. These processes are often asynchronous, involve multiple steps and require gathering information from various sources. It can take minutes, hours, or even days. All right. So recently, again, like some even take weeks. If you are really seriously considering a matching of a clinical trial, it's like sometimes even months. Yeah. So recently, I talked about the pain points in prior auth workflows, asking prior auth is friction, can't we just talk? The core idea was exploring how LLM agents embedded in EHRs and communicating via standardized protocols could handle the necessary dialogue, moving beyond today's rigid and often frustrating structured data exchanges. This echoes challenges we faced years ago when I first drafted the CDS hook spec, where we aim to embed external logic seamlessly, but primarily focused on synchronous suggestions via static cards. While useful, that pattern isn't inherently designed for the persistent multi-step asynchronous dialogues that that characterize these more complex tasks. So before that, I think let's go into this particular article, right? I think it's a very simple idea, and this is basically that you can actually have conversation with machines, right? Like now it's possible that two machines with LLMs can have a conversation between each other, and one agent or one LLM might know a lot more about, like, for example, the clinical and EHR context, and the other might be on behalf of the insurance provider, right? So this again, it's a really cool way to think about this. And again, like an EHR agent, which is embedded inside an EHR, just to give you an idea of what Josh is talking about. So he's talking about, okay, there is of course the EHR context. So this is the EHR, and then you have your agent in here, right? So this is your agent. And again, of course, this is an LLM. It might be, it's an open source, closed source LLM. We don't know. But this EHR obviously houses a lot of data. This is a lot of data that's accessible. What we're looking at is this agent can now easily access all of this information, right? So this is where protocols like MCP and there's been a few other protocols, but I think MCP is the biggest one, right? So an EHR agent is able to query the EHR, maybe using a protocol like FHIR or even the database directly, or that particular EHR's MCP protocol, and then it's able to say, okay, checking if this particular drug for patient David Lee needs prior auth. Here's the basic context. So it collects all of this and then it sends it out, right? It sends it out to into the void. And again, on this side, you have another side to this, right? So this is the payer. And again, the payer also has different policies. They have different data. And again, this is policy. And this is also another agent, right? And this is agent to agent communication. There is another protocol by Google that is doing agent to agent communication really well. We'll also get into that. But right now, let's get back to this particular thing, right? Like EHR agent, checking if this particular drug for the thing needs prior auth. Here's the basic context. Now, the prior auth tool or the prior auth agent might say, yes, prior auth is required. Need clinical evidence, radiology diagnosis, this is rheumatoid arthritis diagnosis, MTX trial greater than 3 months, failure or intolerance, recent severity activity score, severe activity score, negative TB screen, provide narrative documentation. And then the EHR agent goes again, like, okay, internally queries this and does whatever, this is MCP or FHIR or whatever it is. Okay, found all of this, synthesizing this summary, and then finally send summary. Here's the clinical picture. Then the prior auth tool, again, like from the payer side, says, reviews all of this, looks mostly good, but the MTX trial duration isn't explicitly confirmed as greater than 3 months in this summary. Please provide specific documentation for that point. EHR agent, again, like searches it internally, found all of this, MTX ineffective for 4 months, sending that specific quote. And the prior auth tool is saying, okay, received, that confirms the documentation required, approved, here's your number. EHR agent updates this, says PA secured. So again, like this is like, why is this different? You're talking about local intelligence, embraces nuances, and like there is the flexibility. It's not based on one single protocol, but it's based on dialogue, right? Like you have multiple agents naturally communicating between each other and like finding what's in this context, what's in that context, and then finally they either come to a conclusion or they it says that, hey, you can't have prior authorization for this, I'm sorry, right? But then these are agents in different data contexts, right? Like, so one agent is within the EHR context, whereas the other is within the payer context, and they are both representing two different ways of like actually looking at the same information. And there is some adversarial relationship here as well. But let's come back to this article, right? So let's come about this. Last week I shared demos showing agent plus tools pattern in action, leveraging the MCP to let an LLM securely use tools against real EHR data fetched via Smart on Fire. This reinforced the idea that our focus should be on robust data access, FHIR, and interoperability protocols, MCP, letting capable agents handle the dynamic parts. So what I think Josh is arguing against here is that all, I think I'm not sharing the right screen here. So okay, cut this. So last week I shared a demo showing the agent plus tools pattern in action, leveraging the MCP to let an LLM securely use tools against real EHR data fetched via Smart on Fire. This reinforces the idea that our focus should be on robust data access and interoperable tools like protocols like MCP, letting capable agents handle the dynamic parts. Now, again, like I think what he's arguing about or arguing against here is to have this dynamic part be done by something like FHIR, for example, something like Da Vinci protocol, or this is so dynamic that you don't want to put a standard in and say that this is the only things that you can exchange, right? Then it becomes a back and forth of like, it's basically emails, but then it's complicated emails, right? Like you, instead of just sending normal emails, you are now sending it through a FHIR bundle, you are doing like FHIR messaging and so on. So having two intelligent agents talk to each other. And here I think we have this A2A protocol by Google as well. This is the agent-to-agent protocol that is meant for agents to communicate with each other. So I think a lot of interesting work being done here. I'm pretty sure, I think Josh is also aware of most of what is going on here. So again, for those of you who are not really into the scene, so MCP, okay, just drop the pencil there, but MCP is when an agent is able to talk to data within a particular server, right? Like, so this is where MCP would come in. Again, this agent, if it wants to access this particular database, then this will be done through MCP. But then when these two agents are talking with each other, then that's kind of where the A2A protocol comes in. So it's a slight difference, but then it's meant for this particular thing. And I think Google has also done a pretty good job at like explaining what this is. So there's a remote agent, there is this particular client agent, and you can just like securely collaborate and provide proof that particular documents exist and so on as well, right? So let's going back to the article. But how do we manage these agent interactions within the EHR user experience, especially when delays are inherent? So now we are talking about what happens if there is going to be a delay, there needs to be some information. How do we talk about the UX, right? This brings us to a UX paradigm I call liaison model, right? Imagine the internal LLM agent embedded within the EHR, the liaison. Its primary role isn't to be specialized, isn't to be the specialized external tool like the payer's prior auth engine, but to orchestrate the interaction with it, acting as an intelligent intermediary between the EHR user, EHR data, and the external agent. So again, let's try to break this down. So there is an entity called the liaison agent. It's primarily, it is doing the role of, it is not the specialized external tool, right? So in this case, the payer's engine is doing that. It's just orchestrating the different interactions with it, right? So, okay. In our case, I think it would just be this particular thing that we've drawn. So this particular agent will be our liaison, right? And yeah, I think overall, this is a new style that I'm trying. Let me know down in the comments if this works for you, if it helps you understand things better. I just like whiteboarding quite a bit, so I thought I'll just do this on my iPad. But yeah, I mean, any comments or feedback is appreciated. So going back to the article, right? So let's take a look. So perhaps the most critical function of the liaison, again, he's talking about the A2A as well. So when a workflow event triggers a need for an asynchronous task, the liaison initiates a task representation. It then identifies and communicates with the appropriate external agents, potentially using standardized protocol like A2A framework for managing the conversation. Again, this is the one by Google that we just saw. Crucially, the liaison leverages its secure internal access to EHR data via FHIR APIs or SQL APIs, like most people are still on SQL. So, and its own toolkit, perhaps using MCP defined tool runs locally/securely to proactively gather context and attempt to fulfill the external agent's requests. It manages the task's lifecycle through various states: submitting, working, needs input, completed, failed, while the FHIR standard itself offers a robust task resource that could model this state in detail. The focus here is on the user-facing experience. Perhaps the most critical function of the liaison is mediated user interaction. It handles the automated back and forth with external agents only when it encounters ambiguity, requires clinical judgment, and it cannot derive or hits necessary human checkpoints. Does it pause that thread and flag the task as needing user input, presenting a specific targeted request within the task's context. At the same time, all the liaisons work is transparent, available for the user to review or audit at any time. So again, we are really talking about, I think, let's see if there's some diagrams here. No, I think we'll have to draw some ourselves. So basically what we're talking about here is, you have this back and forth, but at some point, there is something that the model does not understand, right? Like it's like, oh, what should I do? I don't understand this. And then it basically goes all the way back to our user, and then it offers them some sort of a UX, right? It asks, okay, I need this particular thing. Can you answer this particular question? And then like submit, right? Yes or no. So this is basically like what we are talking about, where there is a back and forth interaction, and then it comes back to the user. If it needs something, it may ask, for example, like, hey, I'm not very sure about this particular drug that you prescribed. Can you explain to me more? Right? And that becomes the conversation that the practitioner can have with the agent, and then clarify a few more things, right? And again, this could be structured data, but it could also just be natural language conversations with the agent, right? So the UX model matters because it embraces the reality of these complex clinical tasks. Many could theoretically be fully automated, but often require human intervention for validation or handling edge cases. Even fully automated agent interactions might involve multiple turns and delays. We need a user experience that acknowledges asynchronicity, provides visibility without constant interruption, manages complexity by hiding intricate details unless requested, and facilitates focused user input when necessary. Again, this kind of like reminds me of that meme where there is two people are sending emails, LLM long. Let's see if I can find this. Yeah, there we go. So this I think it will probably turn into something like this. I don't know. Like let me know what you think. But AI turns a single bullet point into a long email I can pretend I wrote. AI makes a single bullet point out of this long email I pretend I read. Right? Like so, there are two ends. So in this case, I think this just becomes like one side is basically the payer. Right, like, and then they're like, oh, here's all the different things you need. The other side is basically the provider trying to give as little information as possible, and then the LLM just like generates as much as possible and sends it to the other side. So I can obviously see that being a meme here. Like maybe we'll make one for this, but yeah, let's going back, right? Going back to our article. The underlying technology protocols like A2A for structuring dialogue, MCP for defining tool use, and agent development toolkits like LangChain/LangGraph or Autogen for implementation provides the necessary plumbing. This discussion centers on the UX layer built around this thing. So how would this UX look like? Inline initiation and subtle status. When a task like a PA request begins, an inline status indicator appears next to the relevant order. It's initially unobtrusive, perhaps a small grayed out icon highlighting PA submitted. The user acknowledges the background process and continues working. Loud signals for action. If the liaison needs human input, the indicator becomes visually louder. A more prominent icon, maybe a question mark, in a noticeable color like amber, with text like PA need input. It attracts attention to specific items requiring action. And then contextual task details panel. Clicking the indicator opens a dedicated panel. This provides the current status, a transparent messaging history showing the liaison agent's interactions and the reason for needing input. Any generated artifact like draft forms or results, and importantly, a focused input area that only appears when the status needs input. Presenting the specific questions from the liaison. And seamless, again, like let's try to like just summarize all of this. So let's go down. So you have a normal task, right? You have a particular box. You're trying to prescribe a particular drug. It doesn't do much. It just like it says like, hey, okay, this is processing. And it's very similar if you've seen something like OpenAI's Codex, right? Like if you want to submit a task, you are actually able to do it. It just works in the background. And then here, the agent is actually doing, I think this is an agent, is a robot, like just assume this is a robot. It's doing the back and forth with the insurance. It's doing all of this. And then finally, when there is something that it doesn't know, it doesn't understand, then it comes back, right? And then once it comes back, then we have the same sort of thing. But then here it says, right, it's something visually more louder. So it's like something like info needed. And of course, there is a button that you can use. And then from here, this goes into another panel, right? Like, so you're able to open up a bigger panel, and then this has all of the context. It says, okay, this is the task, this is the thing, here's what I've done, maybe a timeline of different events. And then, okay, what do you need right now, right? Like, what do I need right now? Just submit this particular thing, answer this particular question, and submit as something, right? So, seamless handoff and quiet resumption. The user provides the requested information in the panel, the liaison processes it, sends it along, and the indicator reverts to the quiet working state, right? So again, like we come back, and then it again goes back to this particular state. So the task inbox, integration and overview. While inline indicators often offer context, the clinicians need a consolidated view. Liaison managing tasks, again, it can come in your inbox. It can show that which things require attention, right? I really want to show you what OpenAI Codex has done. Hey there, this is Siddharth from the future, and I just wanted to show you what OpenAI's Codex looks like just for the UI of these asynchronous tasks. So, for example, let's say I have a repository here. I have a particular task that I wanted to do. So in this case, I'm just saying, okay, go ahead and find some potential security issues in this particular code base, right? And then I'm just going to say ask, and look at what it does, right? Like it creates a new task. It goes off, it's doing its own thing. and then it's saying like, okay, it's working on your task, it's doing all of this. And here again, there are a few things where I've already done this before. In this case, for example, it's done. So it's come back with a bit more of feedback. So it says that, okay, it's made some code changes here, it's doing all of this. But then in this case, it's saying, okay, it's actually failed. Here it's also giving me an update on like what it's actually doing. So I can go inside and I can actually see, okay, that it's setting up the container, it's actually downloading this particular repository. And here I can see the notification, right? It's doing this. Now, while this is happening, I can also like, again, like it detected the Node.js version, Python version, all of this is pretty cool. Now, while this is happening, I can actually say, okay, you know what? I want to open up another repository, and then I can say, I want to make restified interfaces. So this is again just another feature that we kind of are working on. We're forking a bunch of different things, but then I can just ask it to code, and then it will just do it. It'll just go ahead and it'll that's another activity that it'll just start doing, and I can at any point always see what is happening with that particular task. So I can see the parallels here to an asynchronous workflow in healthcare, right? Where you create a particular prescription for a patient, and then you don't know the pre-authorization status, but then you're just able to see like, okay, what's going on, and then it's able to tell you in detail, for example, okay, chatting with the other agent, or it's actually approved, okay, no, it failed, you need to provide more input or information. So that's basically, again, like this is an input ask. It's asking me for like, okay, what do you want to do now? Do you want to create a pull request or whatnot? And up here I can always see like what are all the different things that are going on, right? So I actually think this is a really good UI or UX for AI to like sort of work on asynchronous tasks. But again, yeah, back to the video. So this Liaison UX pattern aims to gracefully handle delays, orchestrate complexity behind the scenes, increase transparency, minimize user burden by focusing interactions and maintain context while offering a consolidated overview. Crucially, it enables scalable integration of diverse asynchronous services through standardization. As AI agents become more embedded in healthcare, effectively managing these asynchronous interactions is vital. The Liaison model, leveraging standard protocols and focusing on a human-centered UX that designs for delay, offers a path towards more seamless, efficient, and scalable integration. I am 90% sure this was written by AI. So whenever I see the word seamless multiple times, I feel like it's AI. But anyway, I think overall, I think this is a really good article on like what the future looks like, right? And let me know what you think in the comments down below. What do you think the future of healthcare, specifically like all of these asynchronous tasks, are going to be with AI? And hope you enjoyed that, and I'll see you in the next one.